Hey there, this is a review video covering activities 13 through 22 for quiz 2 of Math 103. Starting with 13, we're working with linear equations in one variable. An equation is anything with an equal sign in it. Solving the equations, you want to get everything with variables over to one side of the equation, everything else over to the other side of the equation. So, in this case, we have parentheses here and a minus in front. We can rearrange that as 4t minus 4 plus 3t, because the minus distributes to both 4 and to the negative 3t. Over here we have 7t plus 2. Subtract 4t. Subtract 3t. Over here subtract 4t and 3t. 7t minus 4t minus 3t gives us 0. On the right-hand side, we still have that negative 4, so we get 2 equals negative 4, which says no solution. Whenever you get something that is impossible, that means that there's no solution to it. Clearing fractions. To clear fractions, to get rid of all the fractions in here, you need to multiply by the least common denominator. Least common denominator in here has to have a 3 in it, has to have a 2 in it, has to have a 4 in it, but 4 is 2 times 2, so the least common denominator is 3 times 2 times 2, or 12. Multiply everything by the least common denominator. 12 times negative 1/3 x is negative 4x. 12 times 5 halves. 12 times 5 is 60, divided by 2 is 30. 12 times negative 4x is negative 48x. 12 times negative 1/4 is negative 3. That's clearing fractions. After you clear the fractions, then you continue on like normal, getting all the x's to one side, getting all the other numbers to the other side. Negative 3 minus 30 is negative 33. Divide by 44. Divide by 44. Clearing decimals is similar. When we cleared fractions, we multiply by the least common denominator to get rid of the denominators. Clearing decimals, you multiply by whatever it takes to get rid of all the decimals. In this case, we have a single decimal place, so we multiply everything by 10. If we do that, 10 times 0.7 gives us 7, w plus 4. 10 times 0.3w is 3w. 10 times 0.2w is 2. 2w plus 10. 10 times 0.8 is 8. And then you proceed through as per usual. If you reach a point like this, that tells you that instead of having one solution like we did right here, x is equal to negative 3/4, or instead of having no solution like we did right here, this 7w plus 28 equals 7w plus 28 says that you have infinite solutions. Or always true. And the reason that we say that it's always true is no matter what value of w you put in over here, the left side is always going to be equal to the right side. Finally, on this activity, we have this solve formulas for the indicated variable. This is picking out whatever the variable is, in this case h, and getting everything else that is attached to the h over to the other side. So here I would start out by multiplying by 3 on both sides, because this is a 1/3. This is that 3v is equal to pi r squared h. Then I say we've got an h here, we've got a pi r squared attached to it. I want to get rid of that. Divide by pi r squared. That gives us h, because these cancel out, is equal to 3v over pi r squared. Moving on to the next activity, now we have application problems, word problems. It gives you some basic ideas for how to break these down and solve them. Carefully reading the problem is vitally important. Choosing a variable helps you define what you're working with in this activity, what you need to pay attention to. Translating it into English, so basically breaking up the important parts of the equation, or translating it, you write it as an algebraic equation as well, solving the equation, and then finally checking the answer and interpreting the solution. So I will skip through these ones. These first few are essentially making the variable and writing an equation for the second item in here. For instance, this says the concession stand sold 84 more hamburgers than hot dogs. So X hot dogs, hamburgers are 84 more, so hot dogs plus 84 more. This one, B students rode the bus to campus, 1/2 of that number walked to campus. That means that 1/2 times that number of students walk rather than riding the bus. Moving on from there, we now have application problems that we need to solve. It begins with a few that are just find the number. This is practicing essentially the vocabulary. So 5 more than twice a number. To find the variable, n is the number. Twice the number would be 2n. 5 more than twice a number would be 2n plus 5. 5 more than twice a number is equal to, whenever it says is, that means it's equal to 19. Find the number, solve this for the number. Subtract the 5, subtract. Chloe weighs 5 times what Toothless weighs. So Chloe weighs 5 times what Toothless weighs. Chloe plus Toothless equals 48. Chloe is 5 times Toothless, so 5 Toothless plus Toothless equals 48. 6 Toothless equals 48. Toothless equals 48 over 6, which is equal to 8. And that would be pounds. Which means Chloe weighs 40 pounds. Sum of a couple consecutive odd integers. Whenever we're dealing with consecutive odd integers, consecutive even integers, you make a variable for one of those. Let's say the first one is n. And then from that variable, you find what the second one is. So 2 consecutive odd integers. N is the first odd integer. You have to count up 2 spaces to get to the second odd integer. The sum of the 2 consecutive odd integers, sum is plus, is 16 more. So this is greater by 16, so you have to subtract 16. Then 4 times the smaller integer. That's your equation, and you can work through that and solve that. Activity 15 is more linear equations and applications. So here we're getting a lot more complex on these problems. This first one, a couple people combine their coins and find they all have nickels and quarters. They have 8 more quarters than nickels. Coins are worth a total of $4.70. So we have a table that you can break this down into. Nickels, quarters. Here we have the number, the value, and then the total. The product of the number of nickels you have times the value of each nickel is equal to the total. Let's say you have n nickels. The value of each nickel is 0.05, so total would be 0.05 n. Down here, if you have n nickels, you have 8 more quarters than you do nickels, so you'd have n plus 8. 8 more quarters than nickels. Quarters are 25 cents each, so your total would be 0.25 n plus 8. That table lays out all the information that you need to know for this problem, except for the actual equation. Now the actual equation, you've got your total amount of money that in nickels, you have your total money in quarters. Your equation is going to be the total money that you have in nickels and in quarters, which is going to be the sum of these. 0.05 n plus 0.25 n plus 8, money of nickels plus money of quarters, is equal to money total. Multiply this out, 0.05 n plus 0.25 n plus 2, because 0.25 times 8 is 2, is equal to 470. 0.05 plus 0.25 equals 0.3. Subtract 2 from both sides, make it 2.70. Now I don't like to deal with the decimal, so let's multiply everything by 10. That gives us 3n equals 27, gives us n equals 9, using that n plus 8 is equal to the number of quarters. Here's another one. Alex and Jenny are on a road trip. They're at a rest stop. So let's lay out the table. Alex, Jenny. So for all problems with speeds and times and driving and all that stuff, they're all run by a formula: distance equals rate times time. Rate, time, the product of the two is equal to the distance. For this table, we need to have a column for the rates, column for the times, and then the product of those two gives us the column for the distances. Jenny leaves first at the rest stop driving 60 miles per hour. Her rate is 60. Alex is going faster at 65. That's his rate. We know the rate column, which means that the variable has to be in our time column. Choose whoever you want to get the variable. Jenny's driving for t hours. Alex is leaving 30 minutes later, so this should be t minus 1/2 hour, because he leaves half of an hour later. Distances, 60t, 65, t minus 1/2. Now, they both begin at the same place. They're both driving, and Jenny drives for we don't know how long, and Alex drives until he catches up with Jenny. So at the very end, their distances are the same. The distance that Alex drives is 65, t minus 1/2, is equal to the distance that Jenny drives of the 60t. That means your equation is 60t is equal to 65 t minus 1/2. Do some algebra. Here we've got a negative divided by a negative, so this becomes a positive 65 over 10, which is 6.5, and that's hours. So Jenny drives 6.5 hours, which means it takes Alex half an hour less, so 6 hours, to catch up. Here's another example. Car and truck leave the same intersection, traveling in the same direction. Truck is traveling 30 miles per hour. Car is traveling at 42. Car, truck, rate, time, distance. Rate times time is equal to distance. Car is going 42 miles per hour. Truck is going 30. Time, we don't know the time. They're both traveling for the same amount of time, though. They both start out at the same time, both going in the same direction. What time will they be 9 miles per hour? Or 9 miles apart. Distance here is 42t. Distance here is 30t. So now let's draw some arrows to see what's happening. Here's the car, racing along at 30 miles per hour, or 42 miles per hour. Here's the truck, going along slower. He's behind. But the distance that he's behind by when they stop is 9 miles. So you can say 42t minus 30t is equal to 9, or you can say 30t plus 9 is equal to 42. A couple different ways you can set this up. Either way, you should get the same result. 9 is equal to 12t. T is equal to 9/12, which is equal to 3/4, which is equal to 45 minutes. This says, at what time will they be 9 miles apart? Well, they left at noon. They drove for 45 minutes. They should be 9 miles apart at 12:45 p.m. From there, we make a major switch over to equations involving absolute value. This one has equalities with absolute value. The trick with equations with absolute value is breaking them up into two different equations. R minus 1 equals 4. R minus 1 equals negative 4. Which says R is equal to 4 plus 1, or R is equal to negative 4 plus 1. Two different solutions. One important thing to note with absolute values is that an absolute value equation can only be broken up once there's only the absolute value by itself. So something like this, you'd have to subtract the 6 to begin. You'd have an absolute value of 1/4 plus v is equal to negative 1. And in this case, that would say that you have no solution. Because an absolute value can never be a negative number. Up here, however, you would subtract the 2 and then break it up into two different equations. Absolute value of 1/4 n minus 3 is equal to positive 3, and it equal to negative 3. If there are two absolute values, then you essentially do that same thing. 2w minus 3 equal to w plus 9. 2w minus 3 equal to negative w plus 9. And work through with both of those. The final odd case is if you have it equal to 0. Instead of breaking it up into two different equations, well, when it's equal to 0, you don't have a negative and a positive version, so this would just mean that 4p plus 5 is equal to 0 exactly, and then you'd solve that through to get p is equal to negative 5/4. There'd only be one solution in that case. I'll work through this one. And here I just skipped showing the negative sign in there and then distributing it, but you do need to be careful with the negative signs that you distribute them to both things here. On both of these, you want to get the variable to one side. Here it's subtracting 10a, here it's adding 10a. Subtracting 1, subtracting 1. If we do that, we have negative 2a minus 10a gives us negative 12a. Positive 3 minus 1 makes this equal to positive 2. Or over here, negative 2a plus 10a gives us 8a. Negative 3 minus 1 is negative 4. Divide by negative 12. Divide by 8. This means that a is equal to negative 2 over 12, which simplifies to negative 1 over 6. Or a is equal to negative 1 over 2, because 4 over 8 divides down into 1/2. Those are your two solutions. After the absolute value equalities, it feels like we change up what we're talking about significantly and talk about linear inequalities. For linear inequalities, we're working with graphing where things are on a number line. So x greater than negative 2 says find negative 2. Choose wherever you want negative 2 to be. And say x is greater than negative 2. But it's specifically not equal to negative 2. It's only greater than negative 2. Less than negative 2. Not equal to negative 2. Only less than. Greater than or equal to negative 2. Now we have a filled in dot going that way. Try to have the line be sort of parallel to this, not like all wonky and off like that one. Less than or equal to -2, that's -2, can be equal to or less than. Then we have two different set notations. We have set builder notation, which has curly brackets and that vertical line. Curly brackets means it's a set of all x. Vertical line means such that x is greater than -2. Interval notation says this is the interval from -2 to infinity. Specifically, it does not include -2, because for interval notation, we have round bracket means not include. So that's very important to pay attention to here. With set notation, less than or equal to, square bracket, equals endpoints. Simply less than or parentheses, round brackets, means does not equal. Or the interval does not reach the ends. And that part about not reaching is why we only use parentheses, never brackets with plus or minus infinity, because you can never reach infinity. Infinity is not a number. Infinity is a concept of something that is massively large, either positive or negative. So an interval will go towards infinity, but you can never actually reach infinity. Solving the inequalities is almost exactly like solving equations with one twist. If you're dividing or multiplying by a negative number, it reverses the order of the inequality. Here, we don't divide or multiply by a negative, so you start out by adding 2 to both sides. That gives us 5x greater than or equal to 15. Divide by 5, divide by 5, x greater than or equal to 3. So you go to 3, you label it, you say it's greater than or equal to that point of 3. Set builder says it's the set of all x such that x is greater than or equal to 3. Interval notation says it includes 3. You always want to work with the left to right points, and it goes up to infinity, essentially goes on forever in 3. Words, set of all x such that x greater or equal to 3. This one, divide by -6, divide by -6. That means that m is less than, reverse the direction of the inequality whenever you're dividing or multiplying by a negative number. X is less than 15 divided by 6 simplifies down into -5/2. Go to -5/2. It's less than but not equal to. Goes down like that. Set builder, curly bracket x such that x less than -5/2. End curly bracket. Interval, leftmost point to rightmost point. Leftmost is -infinity because it goes down forever. Rightmost is -5/2. Does not include -5/2. Then words, basically the same as this, set of all x such that x is here greater or less than -5/2. And that's essentially what this entire activity is. Moving on from there to activity 18, we have compound linear inequalities. So when you have multiple inequalities at the same time. Here are a few examples. So for this one, we are working with and. And means only both at the same time. Has to be in both intervals at the same time. So the first interval is y is greater than -3. Second interval is y is greater than 5. Neither are equal to. That's second interval. This is first interval. When it's talking about one interval and the other, it's talking about only this overlap right there. It's going to be from 5 up to infinity that they overlap. For this next one, 2x plus 3 greater than or equal to 1. That means that 2x subtract 3 greater than or equal to negative 2 divided by 2x greater than or equal to negative 1. Over here, x plus 5 less than 9. Subtract 5 from both sides, x less than 4. Graphing those, x greater than or equal to negative 1, equal to or greater than x less than 4. Not equal to, less than. One and the other only talks about the overlap, so it only talks about this. Now the endpoints you need to be careful of. This one is included, this one is not included. From negative 1 up to 4, inclusive of negative 1, exclusive of positive 4. Another example, moving on to the next page, you can have double-sided inequalities. So this says that negative 7 is less than or equal to negative 2x minus 5, which is less than 3. When you have a situation like this, you do the same thing to every single piece of this at the same time. We have negative 5, so we want to add 5 to all three pieces here. Negative 7 plus 5 is negative 2. 3 plus 5 is 8. We want to get rid of this negative 2. You divide everything by negative 2. Negative 2 divided by negative 2 is positive 1. You divide it by a negative number, so you have to reverse the direction of these. 8 over negative 2 gives us a negative 4. 1 is greater than or equal to x, which is greater than negative 4. Negative 4, positive 1, including, excluding, that's your interval. Negative 4 to 1, including 1, excluding negative 4. Activity 19 is similar to activity 18, but now we're working with or with union instead of and. Or in mathematics means that it's in one thing, or it's in the other thing, or it is in both. So this first example, x is less than negative 4, or x is greater than or equal to 0. In the previous activity, this would have no solution, because there is no place where it's one interval and the other interval. But now we're working with or. One or the other, or both. So the solution to this is everything up to negative 4 and everything past 0. So we'll actually have two separate intervals here. We'll have everything from negative infinity up to negative 4. And we'll also have everything from 0, that's included, up to infinity. We need some way to tie those together, and that's where the union symbol comes into play. Union symbol says we take the first interval and the second interval, and we tie both of those together. So it can be in this interval or in that interval. Other than that, the activity proceeds essentially the same way with these inequalities. It wraps up with a little bit of writing inequalities from words. So a student must earn no more than $20,000 per year. No more than means that they can earn less than, or they can earn exactly equal to that. So this would be student, let's say S equals student income. So this would be S is less than or equal to 20,000. Diane exercises more than 40 minutes per day. Way to go, Diane. It's not like she's exercising exactly 40 minutes. She actually exercises more than and only more than 40 minutes per day. And the principle continues on for the next ones. Activity 20, inequalities involving absolute value. So we're taking the absolute value equations and the inequalities and combining those into a single activity. For the absolute value equalities activity, we broke each absolute value up into two different pieces. We had the negative and the positive version. For this, we do it almost exactly the same, except for the negative version just goes down here to the left. You say the negative version is less than that, positive version is greater than. Same thing here, negative 3 less than or equal to m, which is less than or equal to positive 3. This, when we graph it, will always look something like this. In this case, it's not equal to, so both of these will be open circles. That's what the absolute value inequality looks like when the absolute value is less than something. Additionally, just like with the absolute value equalities, we can only break them up when we only have the absolute value on one side. So something like this, we would have to begin by subtracting 4 from both sides. And at this point, we can now break it up into the negative and the positive version. And then solve it. Activity 21 continues on with absolute value inequalities to have the absolute value be greater than something, and also special cases of the absolute value. So absolute value greater than something, we can still sort of treat it the same, but when we get to the end of it, it will be a little bit different graphing. So we can still be negative 10 greater than p greater than 10, but the issue is with how this is ordered is essentially this says negative number greater than something which is greater than positive number, which sort of looks like negative number greater than positive number. So we can break it up like that, and then you have to think about this as two different sections. Negative 10 greater than p, negative 10 is greater than p, and positive 10 is less than p, like that. And the reason that we want to be able to do this is because it makes our life easier when we've got algebra to do. This one, for instance, negative 7 greater than 8q plus 9 greater than 7. Now I can do all the algebra to all of it at once, keep everything nice and tidy, and then break it up afterwards. Break this up into the two different pieces. Negative 2 is greater than q, and q is greater than negative 1/4. Got negative 2, negative 1/4. Q is greater than negative 1/4, and negative 2 is greater than q. So your interval here will be negative infinity up to negative 2, and your other interval will be negative 1/4 up to infinity. And those two things have to be tied together by the union symbol, showing that anything in this set is a solution and anything in this area is also a solution. I'll do another example. Step 1, we have to isolate the absolute value. And then after we solve this down to have only the k there, again we have to break it up into negative 22 greater than or equal to k greater than or equal to 6. Negative 22, positive 6, k is greater than or equal to 6, Negative 22 is greater than or equal to k. Our intervals, negative infinity up to negative 22, includes negative 22, union with including 6, all the way up to infinity. The final case here are the edge cases. Absolute value of p plus 4 greater than or equal to 0. An absolute value is always going to be greater than or equal to 0. So this one is always true. Next one is absolute value less than a negative number. That's never true. The final one is this interesting case. Let's subtract a 3 from both sides so we can see what's going on. This says absolute value of 6y minus 1 less than or equal to 0. If it's less than a negative number, it's never true, but if it's less than or equal to 0, there's one situation where this is true. That's when it is exactly equal to 0. So this right here says 6y minus 1 is equal to 0. Solve this through to get the single point where that is true. Final activity for the quiz is activity 22, linear equations in two variables, essentially graphing. Important thing to keep in mind is that these ordered pairs are ordered as x, y, alphabetically ordered. The x-axis is the horizontal, while the y-axis is vertical. The examples in this are primarily plotting points. So x-coordinate, y-coordinate, find the x-coordinate of 6, go to the y-coordinate of 2. That right there is your point 6, 2. Negative 3, negative 4, x equals negative 3. Excuse me, I said that backwards. That right there happens to be negative 6, 2. Positive 6, positive 2 would be all the way over here. Positive 6, positive 2. Negative 3, negative 4. You go negative 3 in the x, negative 4 in the y. Get down here. Do the same for the rest of those points. This is talking about quadrants of this. So the quadrants are quadrant 1, 2, 3, and 4. Goes around counterclockwise. Quadrant 1 is here. The x-coordinates are going this direction. X-coordinates are all positive. X-coordinates of every point in quadrant 2 over here are going to be negative. Y-coordinate of every point in quadrant 4 going down here, going to be negative. Y-coordinate of every point in quadrant 2 going up, positive, and so on. This asks determine whether each ordered pair is a solution. This is the ordered pair. This is the equation. The process is plug in the x, y values to this equation. Negative 2 times x value, negative 8, minus y value. Is that equal to 13? Negative 2 times negative 8, positive 16, minus 3. That's equal to 13. That's a check. The question is, does 11 equal 5 times 3 minus 6? Does 11 equal 15 minus 6? Does 11 equal 9? Not a solution. From there we have some more graphing. Graph each equation using a t-table. So for this you choose random numbers for x, find the values for y, plot the 3 points, and then draw the line. So there are no right or wrong answers for the values for x, but your life is probably going to be easier if you choose negative 1, 0, and positive 1. Most of the time those are the easiest values. If x is equal to negative 1, we've got negative 2 times negative 1, which is positive 2, plus 5, which is positive 7. So y equals 7. X equals 0, y equals 5. If x equals 1, y equals negative 2 plus 5, which is negative 3, or positive 3. Your points, negative 1, 0, and positive 1. Y value of 7, y value of 5, y value of 3. There are your 3 points. Now draw the line. Finally, we are given the equations of some lines. We're supposed to plot 3 points and label the coordinates when we graph. So, first thing we want to find the intercepts and one other point. So to find the intercept, the y-intercept is when x equals 0, the x-intercept is when y equals 0. So when x equals 0, you find y. When y equals 0, you find x, and then I'm going to use x equals 1 for the final point. If x equals 0, 2y equals 10, which means y equals 5. If y equals 0, then 5x equals 10, which means x equals 2. If x equals 1, 5 times 1 plus 2y equals 10. 2y equals 10 minus 5, which is 5. Y equals 5 halves, or 2.5. So there are our 3 points. When x is equal to 0, right there, y is equal to 5. When y is equal to 0, x is equal to positive 2. When x is equal to 1, y is equal to 2.5. There are our 3 points. And here's our graph. Hopefully that was helpful for you, and I wish you the best of luck on the upcoming quiz.